Bismillahirrahmanirrahim. We continue for chapter 2, analog to digital conversions. So at the end of this chapter, the students are able to construct the ADC circuits. So in this chapter, we will go through on flash ADC circuits, counter ramp ADC circuits, and successive approximations ADC circuits. Before we continue with the ADC circuit, this is the general of ADC process to convert the inputs analog signal to outputs digital signals. So in this process, we have two steps. The first is sampling and holding circuits, and then the second one is quantizing and encoding Q and E. So the sampling and holding circuits, holding the signal benefits the accuracies of ADC conversions, and minimum sampling rate should be at least twice the highest data frequency of the analog signal. If you look at the signals for the continuous signals to sampling pulse and sample signals and into the sample and hold signal. So by the process of sample and hold signal, so our signal become the sample and held signal at this signal lah. So this is signal yang akan dapat melalui proses sample and holds. Okay, and then for quantizing and encodings, so based on the resolutions, the smallest change in analog signal that will result in the change in digital outputs. So this is the resolutions, voltage resolutions equal to voltage reference, which is the range of V maximum tolak V minimums divided by 2 power of n. So the resolution represent the quantization error inherent in the conversions of the signal to digital forms. Okay, and then in terms of the accuracies of analog to digital conversions, there are two ways to best improve the accuracies. First, increasing the resolutions, which improve the accuracies by measuring the amplitudes of the analog signal, and then increasing the sampling rates. Okay. So if you look at this graph, by increasing the frequency of the sampling rates, so our accuracies of ADC become improved for this graph lah. So these resolutions also increase. Okay, and then we move to flash our first ADC circuit, which is flash ADC. So this flash ADC consists of series of comparators, each one comparing the input signal to the unique reference voltage. So the comparator outputs connect to the inputs of the parity encoder circuit, which produce the binary output. For example, here we have this the comparators. So this is the output. Okay, and then this is, we have, for example, the VA, and then this for VB. So we compare whether VA greater than VB. Okay, for example, if VA greater than VB, so the output is high. Okay, and then if VA less than VB, so the output is low. Okay, so that is the comparators lah. Okay, and then the flash ADC is a conversion time, TC. TC is a conversion time of ADC, and the shortest but require a loss of comparator circuits. So in general, macam mana kita nak tahu bilangan comparator is depend on 2 power of n here. Okay, 2 power of n minus 1. So for example, if our bit is 3 bits, so our numbers of comparator 2 power of 3 minus 1, so equal to 7 comparators. Okay, comparator. So numbers of bit akan limit numbers of comparator lah. For example, if 6 bit flash ADC required 63 comparators, and if 8 bit, that required of 255 comparators. And then this flash ADC, the form in IC. So typically available yang biasa ada untuk flash ni adalah 2 bit to 8 bit. Okay, this is the flash ADC. For 3 bit flash ADC, that the voltage resolution is 1 volts and produce the output digit 3 bits. Okay, the input analog VA used as a comparators. So dia akan compare input here, VA yang akan masuk kat sini. This is VA. So dia akan compare dengan output kat sini lah. This is voltage resolutions for V1. Okay, to calculate V1, so by using the voltage divider, so V1 equal to R divided by, because of number of resistor 8, so 8R, okay, multiply with voltage reference. So that's why in designing the flash ADC, we make it for depends on the resolutions. To get the resolution 1, so the numbers of resistor become 1K, and then 8 multiply with 1K, 8K, the reference is 8. So kita akan dapat 1 volt for V1, V2 is 2 volt, V3 3 volt, V4 4 volt until V7 7 volts. So like I mentioned before, 3 bits required 2 power of 3 minus 1 equal to 7. Comparators we have C1 until C7 lah. Okay, comparators. A voltage divider network comprising 8 resistors are used to set the reference level for each comparator, so that there are 7 voltage levels yang mana saya beritahu tadi by using the voltage divider. And then the resistor can be selected depending on the level of reference voltage and the desired digital outputs. Okay. When VA less than 1 volts, the output comparator C1 until C7 become high. Okay, for example VA kita ni, okay, VA kita ni less than 1. Okay, less than 1 for example VA. Okay, so kalau VA less than 1, it means that voltage dekat plus ni akan greater than. So VB ataupun VA ni akan less than 1. So output C1, C2, C3 until C7 will be high. Okay. So when VA greater than, okay, VA kita greater than 1. So for example 2, okay, or 1 for something. So 1 or more output comparator become low. It depends on the level of reference that we compare. Okay. So the priority encoder will produce the binary digits or number that corresponding to the highest input enables. Okay. So we look at the example here. When the analog input voltage VA between 4 and 5 volt. Okay, 4 volt to 5 volts. Okay, for example VA kita 4 point something lah, for example. Then the output comparator C1, C2 and C3, C1, C2, C3 and C4 become low. Okay, kenapa? Because of, if you look at here, V4, this is V1, V2, V3, V4, ni V5. So kalau kita punya voltage kita, okay, kita punya VA kita adalah 4 point something, it means that V1, V2, V3 akan lebih rendah daripada VA. So comparator C1, C2, C3, C4 akan menunjukkan low. So and the comparator outputs is high lah, because of the VA less than dia punya voltage. So that's why here kalau kita tengok 4 volt to 5 volt, so C1, C2, C3, C4 become low and other comparator become high. So this is the outputs of flash ADC when the VA between 4 volts to 5 volts. Okay. So for example, if our VA kita greater than 7 volts, so our output flash ADC become 1, 1, 1, 1. Okay, 1, 1, 1. Okay, now we go for example 1. Okay, design the 2-bit flash ADC with voltage resolutions 1 volt and produce the output digit to 2 bits. Okay, first kita akan buat priority encoder. This is priority encoder. So output kita adalah 2 bit. It means that this is the A, this is the B, less significant bit and more significant bit. Okay, now kalau kita punya output kita 2, so it means that 2 power of 2 minus 1, so kita akan dapat 3 comparator. Okay, comparator. So 3 comparator, so kita ada 1, 2 dan 3 comparator. Sorry. Okay, so kita akan buat 3 comparator here. Okay, kita akan buat 3 comparators. Okay, so kita akan ada minus, plus, minus, plus, minus, plus. Okay, so kita akan buat kita punya resistor. Sini kita akan ada resistor pergi ke ground. Okay, and then kita akan ada resistor kat sini. Okay, and then kita akan ada resistor. And then kita ada last resistor pergi ke Vref. Okay, and then this is the Vin kita ataupun VA lah, VA input kita, voltage input. Okay, so dia akan compare kat sini. Okay, so untuk dapatkan resolution kita 1 volt, so sini 1 volt, mudahnya kita akan kira sini ada 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm, sini adalah 4 volts. Kenapa? Untuk dapatkan V1 for example kat sini, so kita boleh calculate V1 equal to 1K divided by 4K multiply with 4, so kita akan dapat 1 volt. So that is voltage resolution dia. Okay, now kita nak tengok kita nak buat kita punya table. Okay, so yang ni adalah okay, kita buat yang ni adalah input, voltage input. Yang ni adalah kita punya comparator. Yang ni kita punya output. So output kita adalah BA. Dan comparator kita ada satu C1, C2 and C3. Sini adalah C1, C2 and C3. Kita punya comparator lah yang masuk kepada priority encoders. Yang ni adalah kita punya inputs. Okay, input yang pertama adalah kita punya input yang pertama adalah 0 to 1 volts. Okay, kita punya input yang pertama adalah 0 to 1 volts. So kalau 0 to 1, it means that VA kita akan lebih rendah daripada kita punya reference kita kat sini. So that's why semua kita punya comparator akan high. So kita punya output kita akan 0. So in range 1 to 2 volts, so yang C1 sahaja akan low, yang lain akan high. So result kita yang macam ni. So kalau 2 to 3 volts, so 2 sahaja yang akan low dan result kita akan jadi macam ni. And then kalau greater than 3 volts, kita akan dapat semua comparator akan low. So result kita akan dapat 1. Okay, so for the example, kalau kita nak cari berapa value Vout if VA kita equal to 2.5 volts, so kita tengok 2.5 dalam range ni, so output kita adalah 1.0. Kita punya Vout adalah 10.